All right. Okay, so now you're all in trouble. Yay. Chemical reactions, 4 main types that you need to be aware of. What are some examples, or what are those types that we need to be aware of? Nor? Synthesis. What else do we? Oh. Single, double, and decomposition. Synthesis, decomposition, single and double replacement. Most of you probably feel okay with synthesis and decomposition. Yes, no? You can recognize those. The single and the double replacement is where a lot of you are starting to get confused on which one it is. But I want to take a few seconds and just kind of go through. What is our formula for a synthesis reaction? Off of what you guys were using yesterday and the day before. Jackson, what's kind of our formula for what a synthesis reaction should look like? A plus B yields AB. Okay? 1 plus 1 equals 2 is kind of what we're saying. Remember, we have a couple of things going on. We have the elements that are on the left-hand side of the arrow. We have the elements then that are on the right-hand side of the arrow. The arrow simply means to yield or to make. That is what is being produced or created in a chemical reaction. So on the left-hand side, what do we call those elements? Those are the reactants that are going into the actual equation. And on the right-hand side, those are the products that are actually being created through the chemical reaction. All right? In a synthesis reaction, you have one thing being combined with another thing to give you a new substance. What do we know about the chemical and physical properties of this new substance? They're going to be stable because they have been through that reaction process. But the chemical and physical properties, what do we know about those compared to the reactant side, physical and chemical properties? There's nothing added or taken away, which is our conservation of mass, which we'll get to when we do the wrap process and balancing. But A has its own set of chemical and physical properties. B has its own set of chemical and physical properties. And then A and B will have their own new set of different chemical and physical properties. Anytime they go through the chemical reaction process, what is created is a new substance, and they have their own distinct chemical and physical properties. So synthesis here is simple. A plus B yields AB together. All right? Decomposition. What is that one going to look like in our little formula? Drew? So now we start with A and B as the reactants. They break down into their simpler parts or their original parts, which is A plus B. It is the exact opposite of our synthesis reaction. So we have decomposition. We start out with something big, and it breaks down into smaller parts. AB is combined together. It goes through the reaction. It is now A plus B instead of A and B joined together. Most of you probably feel okay with those two, right? And those are really the easier of the 4 that we need to take a look at. What does single replacement look like? Naya? It's AB plus C, and it's going to yield something, but it's not going to be A and C. It's going to be B and C, and actually it's going to be CB plus A. Mr. Arnold, why is C first? Why is it not? Remember, in a single replacement reaction, what type of elements are going to be used? Metals or nonmetals? Metals, thank you. Metals are involved here. In a single replacement reaction, we have a metal, remember it's first, Ionic bonding, what elements do we always list first? Metals. So we have a metal that is going to be replaced by another stronger metal. We talked about how atoms, when they bond together, are not stuck together forever. If something bigger or better comes along, they are going to change partners, and that's what's happening. C is a bigger, stronger metal. It is going to push out A, so it takes its partner or its place, so it's C, B now together, and lonely old A is out by itself. Yes? How do you know it's better? When we get into chemistry, or when you guys get into chemistry, we'll start taking a look at the attraction forces between different atoms, and there's electronegativity and other things that are involved inside of there. So so again, single replacement, you have one element that is by itself. It is just going to simply replace another element that's in a partnership or in a compound combined together. What does double replacement look like? If we're talking about double replacement, we're talking about a lot of atoms now. Kyrie? You are close. It's going to be AB plus CD. Again, we are just going to have our first element swapping places. So A is going to swap with C, and it's going to form a D. And then C is going to obviously swap with A, so it's going to be CB. Again, we're moving those first elements. Typically, those are our metals in most of our situations. So AB plus CD yields AdCb. And if you take a look, we have, again, our first elements just swapping partners. A came into the reaction with B. It leaves the reaction with D. C came into the reaction with D. It leaves the reaction with B. They're just swapping partners. And that's double replacement. There will be some equations on the assessment that are actual equations like we looked at yesterday and the day before, where you actually see a real-life equation and you have to be able to say this is single or double or whatnot replacement. There will also be some of these style where I give you kind of the generic formula. Can you tell me which one this one is or that one, or so on from there? Are we good here? Even if we're not 100%, we're going to continue to practice, because as we balance equations, I'll ask you the question, what type of equation is this? And you'll have to be able to say synthesis, decomposition, single or double replacement. Why do you think chemical equations need to be balanced? It has to do with whether it will react or not, but it has to be balanced because there's this law that we talked about a little bit yesterday. Conservation of mass says that mass cannot be created or destroyed. It can only be moved or changed forms or changed states, those kinds of things. So a balanced equation simply shows you how an actual reaction is obeying the law of conservation of mass. If I start with 10 atoms of oxygen, at the end of the reaction, I have to have 10 atoms somewhere. Those atoms may bond with other elements. They may bond with themselves to form oxygen gas or ozone. That's fine. But they have to be on the same, or they have to have the same that started with that you end with. So let's take a real simple equation. We have hydrogen gas plus oxygen gas. That oxygen gas is simply going to yield, or that reaction is simply going to yield H2O, water. First of all, what kind of reaction is this? Ben, synthesis. We have one thing plus another yielding one big substance. Hydrogen plus oxygen gives us water. Do you think this equation is balanced? It isn't. Why is it not balanced? What did we already notice without really doing anything? We've got 2 on this side, but we already noticed we only have 1 on that side. So this equation as it stands right now would not produce a chemical reaction. If I took 1 thing of hydrogen gas, 1 thing of oxygen gas, and tried to squeeze them together to form water, it wouldn't happen. So when we balance a chemical equation, we're actually looking for the minimum amount that we need for that equation to actually happen, or that reaction to actually happen. So what we're going to do is set up what we call the RAP table. The RAP table is pretty easy. You have R, A, P, I know, really exciting stuff right here, RAP. What do you think the R is standing for? It's the reactants. It's on the left-hand side. What do you think the P is standing for? Products. It's on the right-hand side. What do you think the A is representing? It's the atoms or the elements that are in the actual process. So if we take a look here, R is the reactants. It's the stuff that's on the left-hand side of the equation. P is the products, which are on the right-hand side. And then A is the atoms. What are we actually using? What elements are involved? So if we take a look up here, what elements do I have involved? I have H, and I also have O, hydrogen, and I have oxygen. So the first step in the RAP process is to just set up your table with your reactant side, your product side, and the atoms in the middle. Now, if we take a look at this, we're going to simply just count. I have H2. What does this little 2 tell me about H? There are 2 atoms of that. What is this little 2 called? Anybody know what that little number is that hangs? It's a subscript. It hangs below sub. It's a subscript. So the subscript tells you how many you have. So I have 2 hydrogens here. How many oxygens do I have? I have 2 as well on the reactant side. Now, if we go over to the product side, we have a 2 right here. Tells us how many hydrogens again? 2 for the products, but we don't have anything over here. So how many oxygens do I have on the right-hand side? 1. If we write this down, if we do our RAP table right to begin with, you can easily see that our hydrogens are good, but our oxygens, they're not good. Conservation of mass says we cannot create or destroy. Well, right now I started with 2, but I only ended up with 1. So that means I've lost 1, and we can't lose anything. Good so far. Now, we cannot change any of the subscripts. The subscripts have to stay the same. All we can change is what is called a coefficient. A coefficient is a big number that hangs out in front. Many of you have used these before. If I gave you this and said simplify this little expression up here, 3 parentheses x plus 2, close parentheses, what would be the simplification of that whole process? It would be 3x plus 6. What property are we using right there? Distributive property. So coefficients are these big numbers out in front that get distributed through the entire equation. Or I'm sorry, not the entire equation, what they're attached to. Meaning this, how many oxygens do I have on this side? I've got 1, right? I want to get it up to how many? 2. What can I multiply 1 by to get to 2? I multiply by 2, right? So if I come in here and I put oh, that's not a 2. And let's see if I can get my eraser to work. And I got it to work. If I put a big coefficient out front, a 2, it needs to be distributed through to each element. Okay? 2 goes to hydrogen as well as to oxygen. How many hydrogens do I have right now? I have 2, but I'm going to multiply it by 2. So 2 times 2 equals 4. I have how many oxygens right now? 1. I'm going to multiply by 2. 2 times 1 is 2. Mr. Arnold, this makes no sense right now, right? You just screwed up the hydrogens. Well, we've changed the hydrogens, but we're trying to find the minimum number that we need in order for this process to actually work. So I've got oxygens that are okay now. Can I change this hydrogen to equal the one on the product side? Yeah? What do I need to add out here to get that to turn to the same number as the product side? If I add a 2 here, I'm going to multiply it to there. So 2 times 2 equals what? 4. How many oxygens do I have? 2. On the product side, how many hydrogens do I have? 4. How many oxygens do I have? Do I have the same amount on each side? Is this a balanced equation now? Yes, it is. Some of you might be asking the question, why did you not multiply the 2 all the way through? The plus separates oxygen and hydrogen. So the coefficient only goes to what it is attached to. Since hydrogen and oxygen are attached on this side, I had to carry it all the way through. But they're separated by that plus sign on this side, so I don't carry the 2 all the way over to that oxygen. It separates those 2. All right? Okay with it? Worried? Nervous? All right, so we're going to take a look at this one again, and we're going to set up our wrap table. So we have our reactants, our atoms, and our products, and we're going to go ahead and separate those guys out. The object is to get the same number of reactants as we have products. So what atoms are we using for right now? We have H, which is hydrogen, and then we have N, which is nitrogen. The first step is to simply count. How many atoms do I have on each side of the arrow, or each side of the equation? And I don't know what I did there. There should be an arrow right there. I apologize. So, on the reactant side, how many hydrogens do I have? 2. How many nitrogens? N2 is 2. All right. On the product side, how many? Now, nitrogen switched places a little bit here, but we're still going to write it down here. How many nitrogens do I have now? I have 1. How many hydrogens? I have 3. Now, the question earlier was, will the numbers always stay the same? And the answer is no. What I like to do is take a look at the numbers that are the most difficult to match up. 2 and 1, we can get those to match up pretty quickly. But a 2 and 3, not so much. Does 2 go into 3? No. So if they don't go into each other, we have to find a number that they commonly go into. What's the number that 2 and 3 commonly go into? 6. So what do I need to multiply 3 by to get to 6? 2. So I'm going to write a coefficient out here of 2. 2 times 3 is 6. That's good. But remember, I've got to distribute it to both parts because they're connected. There's no plus sign. So now I have 2 times 1, which is 2. And I have 2 times 3, which is 6. Are you good on that process? Okay. I've changed this side to 6, but I have only 2 on this side. What times 2 gets me to 6? 3. So if I multiply by 3 over here, I now have 6, but there's a plus sign. That plus sign separates it. The 3 only goes to hydrogen right now. Good? So I have 6 and 6 for hydrogen. Those have checked out. I have 2 and 2 for nitrogen. Those have checked out. Is this a balanced equation? Yeah. Sometimes it's as simple as that. As soon as you fix one, you fix the other, and you're good. Sometimes it keeps going. Naya. Why did I put the line, and you're talking about this one right here, right? Correct? Why did I put that line there? Because I wasn't certain if we needed a coefficient or not. If you don't need a coefficient, you just leave it blank. It's fine. If you do need a coefficient, you go ahead and add it there. I always like to put the line so I can see where I might need to add a coefficient to. Questions?